Good afternoon, students. Myself, Dr. Divya Ghildayal, in continuation with my lectures for your AKTU B.Tech first year engineering physics syllabus. Today, I will be briefing you your fifth unit, laser. Let us see what is the syllabus for laser first. Laser, absorption of radiation, spontaneous and stimulated emission of radiation, Einstein's coefficient, population inversion, various levels of laser, ruby laser, helium neon laser, and applications of laser. Now, firstly, what all is important? You should be knowing the full form of laser. You should be familiar with these words: spontaneous emission, stimulated emission of radiation. There is a numerical relationship between Einstein's coefficient of absorption and emission, the term population inversion, which states that when the number of atoms become more than that of ground state, the three levels of laser system which are in your course, that is 2 level, 3 level, ruby laser, helium neon laser. Let me tell you, for your question paper, if 1 year they have asked you a question on ruby laser in section C, then other year be ready for a question for helium neon laser. If helium neon laser has been asked, then ruby laser will be asked, and a brief applications of the laser system, why helium neon laser is preferred over ruby laser, define the terms spontaneous and stimulated emission of radiation. What do you understand by population inversion? So these were the general questions which have been asked in your previous year question papers, which I told you right now. Okay, now I am beginning with the syllabus of laser. So laser, L-A-S-E-R. What is the full form? This is a section A question. Give the full form of the term laser. Laser stands for light amplification by stimulated emission of radiation. L for light, A for amplification, S for stimulated emission, E of radiation. It means that we go for some man-made technique to stimulate the process of emission of light that is known as laser. The general properties of laser beam are that laser beam is highly monochromatic. It is collimated. It has a very high intensity, highly coherent and directional beam. And the principle of laser is based on the phenomena of stimulated emission. Please do not confuse it with the word spontaneous. It is based on the principle of stimulated emission of radiation. This has been stated by Einstein. Now the three terms: absorption, spontaneous, and stimulated. This question is a very favorite question of section B, where the question setup is like this: define the terms absorption, spontaneous, and stimulated with the help of a diagram in laser setup. Okay, let me first explain you what exactly happens. See, you are very familiar with energy level system. You know that atoms are usually all lying in their ground state like this. When they get energy from any external source, say E equal to h mu as given by Planck's constant, where h is Planck's constant and mu the frequency of the energy incident, only those atoms whose frequency matches, they leave the ground state and rush to the excited state. Here at the excited state, they stay for 10 to the power of -8 seconds, and then they drop down. While dropping down, they emit light. This process is known as spontaneous emission. The word spontaneous means happening on its own. And this was where the atom got absorbed from its ground state, reached the excited state, stayed there for 10 to the power of minus 8 seconds, and finally it dropped down. Now, this whole process is a spontaneous process. We have not done anything in it. And this concept was used in making the laser beam. How? Now you are getting familiar with the word stimulated. That is, in stimulated emission, an incoming photon whose energy as per Einstein's energy equation becomes equal to del E is H mu is incident on an atom which will be excited to state E2. The incoming photon increases the probability to revert the atom back to its ground state, thereby emitting a second photon, and the emitted photon will all be in phase with the incident photon. The process of speeding up atomic transitions to lower level is known as stimulated emission of radiation. See, from the base, it got absorbed. From absorption, after that, via the process of spontaneous transition, it fell down to the lower level. Here, if we put a metastable state is that state where the atom stays for more than 10 to the power of minus 8 seconds, and then it drops down. This process will emit laser light. This is an experiment where we are showing that how laser light will be emitted. See, metastable state, here the time is more than 10 to the power of minus 8 seconds. From this state, when the atom drops down, the process is known as stimulated emission. Earlier one was spontaneous, happening on its own. This energy level will emit laser light. Please remember that in your energy level diagrams. Be very careful. Only that transition which is happening from the metastable state to the next energy level will be emitting laser light. These transitions will also emit light, but that is not going to be a laser light. You have to be careful about this point when you are drawing the energy level diagram in your final exam. So the laser transition happens from metastable state via the process of stimulated emission of radiation, not the spontaneous one. This question has been asked many times, that differentiate between spontaneous and stimulated emission of radiation. Spontaneous is something that is happening on its own. So light here is not monochromatic, but in the stimulated emission, which is my principle of laser emission light, light will be monochromatic, because laser light has the property of being monochromatic. Spontaneous emission, as I told you, is something in which it is like just dropping down to the next energy level. So the intensity of the beam will be very less. But in stimulated, the beam intensity is going to be very high. Spontaneous is a natural process. Stimulated is not a natural process. We have inserted a metastable state here. Spontaneous will not require any external photon to stimulate further ignition, but in the stimulated emission, we require external photon as stimulus to initiate the process. This question is off and on asked. So now, what are the necessary conditions to achieve laser action? The difference between laser light and ordinary light is that laser light is intense, it is monochromatic, it is a very high intensity beam. So population inversion among the energy levels should be there. What is meant by this word population inversion? We know that the energy levels, all atoms are usually lying in their ground state. If by any scientific process we reverse this ratio, suppose N1 number of atoms are lying in ground state E1 and N2 number of atoms are lying in the excited state, where they are always less than the ground state. This is a spontaneous or a natural process. Now we have to revert this ratio. We have to make N2 greater than N1, which will be achieved with the help of pumping in the physics lab. So this process will be known as population inversion. In this case, what is going to happen is that when this atom from excited state will drop down to the ground state, high intensity light will be emitted. But for this population inversion, which means excited state number of atoms are supposed to be higher than that in the ground state. And this process is possible in the lab with the help of optical pumping. Correlated with your home pump. What does a home pump do? It pulls water from your ground and fills your tank maybe to the top floor of your house, and then you use that water for the whole day. Exactly same way, in order to make laser light, we will make number of atoms more in the excited state compared to ground state, so that when the atoms from the excited state fall down, they will be in large number and the emitted light we will get will be strong and of high intensity. The excited state must be having a metastable state. Metastable state means we know by the process of spontaneous process, the atom stays in the excited state for 10 to the power of -8 seconds. If we increase this time of atom of staying in the higher state, then that state is known as metastable state. Use of reflecting mirrors at the end of the system. See, laser light is highly directional. Means, see, laser light, you must have heard very simple applications. If I talk about laser light, are eye surgery, kidney stone removal, used for cutting metals, metallurgy, etc. So the direction of the beam, laser light, should be highly directional. This is possible only with the help of a good mirror setup at the end of my laser system. So with multiple mirrors, what is going to happen is that this light which we have achieved, when it will suffer multiple reflection and refraction, then it will emerge out as a very strong unidirectional monochromatic beam of light. So the use of reflecting mirrors at the end of the system is also a very important necessity to achieve laser action. Okay. Optical pumping for population inversion. Once again, population inversion means when the number of atoms in the excited state become more than that in ground state. This is known as population inversion. Means population invert ho gayi. Abhi ground state pe it was more, excited it was less, but with the help of pumping, what we have done, we have reversed the process. So in excited state, they are more compared to the ground state. Now we introduce the metastable state, and then we make these atoms fall down to ground state, and they will give us laser light. This is also the concept of optical pumping. Next, define population inversion and pumping. Section A question. Population inversion is a state of system. If you want to memorize, there is another way. See it as a simple English word. Population means number of people or number of atoms. Inversion means to invert the process. So in the natural process, number of atoms are always lying in the ground state. If I inverse this process, it will be known as population inversion. So this is a state of system, for example, a laser gain medium where a higher lying energy level is more strongly populated than a lower lying energy level. And when population inversion exists, an upper state system will eventually give off a photon of the proper wavelength and drop down to the ground state. This photon will stimulate the production of other photons of exactly the same wavelength because of stimulated emission of radiation, and we will get laser light. Okay, now a very simple mathematical relation in laser. This question is often asked in your section B question, that derive the relation between Einstein's coefficients A and B. What are Einstein coefficients? Actually, laser is playing the game of absorption and emission. So your famous scientist Einstein gave a very simple mathematical relationship between these two processes. So Einstein's coefficients are mathematical quantities which are just a measure of the probability of absorption or emission of light by an atom or molecule. So I will explain this to you very simple terms. Look at this expression. Absorption equal to spontaneous plus stimulated. Very easy way to memorize this is, look at this energy level diagram. See, energy is falling on these atoms in the ground state. Whatever energy they are absorbing from here, E equal to H mu, only that energy they are using to go to the excited state, stay there and drop down. So what have we done? See, whatever has been absorbed, like compare it in your mind with a water pump. Whatever water has been soaked in by the pump and it has reached your water tank, only that much water you can use for your whole day. So absorption means whatever number of atoms which left the ground state reached the excited state. So whatever energy they managed to absorb, that energy has been utilized in spontaneous emission and stimulated emission. Look at this energy level diagram here. See, absorption took place, E equal to H mu. This energy got used in spontaneous transition and stimulated emission. Stimulated emission gave me the laser light. Spontaneous ones did not give laser light. So this is the expression. Absorption one gave spontaneous and stimulated. Now very easy. Another easy way, let the assembly of atoms in thermal equilibrium at temperature T be taken. Let phi represent the energy density of radiation for frequency mu, and N1, N2 be the number of atoms per unit volume per unit time in energy states 1 and 2. I have written this as a mathematically derived theorem, but it is very easy. N1 will mean number of atoms in ground state, N2 will mean number of atoms in the excited state. And number, now how many have been absorbed per unit volume per unit time? See, N1 were lying in the ground state. B12 is the coefficient of probability which depends on the properties of states 1 and 2 and is called Einstein's coefficient of absorption for radiation. Now this has been absorbed. So see, N1 is B125, means N1 means the ground state, B12 means the constant of proportionality. How many were absorbed from the ground state and reached the second state, and phi. This will be used for spontaneous and stimulated emission. So number of spontaneous emission per unit volume per unit time, N2, A21. Now instead of B, I have written another constant of proportionality called Einstein's coefficient of spontaneous emission of radiation. And then lastly, number of stimulated emission per unit volume per unit time. So N2, B21 and 5 means how many stimulated emissions took place, how many spontaneous took place. I hope this equation is very clear to you. Once again, quickly, I will tell you, whatever was absorbed, that means whatever amount the pump could pull up the water, exactly that much the tank got filled. And now that pulled up water will only be utilized for my experiment. So the absorption gets split into spontaneous and stimulated. Here we have put very simple mathematical value in terms of number of atoms and two constants of proportionality known as Einstein's coefficients, or A and B. So we have just written it in a very simple form like this, divided it by N2 and used two very famous another energy laws, Boltzmann law of distribution and Planck's law of radiation. So we are just what now we are doing, we are writing this equation in a very another simple form. So for that, Boltzmann distribution law, where N1 equal to N0 e to the power of minus E1 by K2 and N2 is N0 e to the power of minus E2 by KT, where K is Boltzmann constant. We will put this N1 here and this N2 here. And N0 is the total number of atoms that are present. K is Boltzmann constant. We divide N2 by N1 and we get the expression as E equal to minus H mu by KT, where H is Planck's constant, mu is frequency, K Boltzmann constant, and T the temperature at thermal equilibrium. From Einstein's expression, del E is equal to H mu. So energy of photon emitted or absorbed. What have we done? See, N2 upon N1 was E to the power of minus H mu by KT. So we just reversed and wrote it as N1 upon N2 becomes equal to E H mu by KT. There is another, we put this value of N1 by N2 equal to E H mu to the power of KT here. And then we get this expression. You can see phi equal to A2, 1. That means transition from the second state to the first state divided by B1, 2. Transition from first state to the second state. So this is a one way of writing the relationship between Einstein's coefficients. You can write it in another way by comparing it with Planck's law of radiation. The derivation is not in your simple. You just have to memorize that Planck's law of radiation is given by phi equal to 8 pi h mu cube upon c cube into 1 upon e to the power of h mu by kt minus 1. So both are expressions of phi. We have compared them, these two expressions, and on comparing, this and this will get cancelled and you will be left with B2 equal to B12. You can try it on your own. It is very easy. And finally, we get the expression for relation between Einstein's coefficients. A21 equal to B21 8 pi h mu cube by c cube. In short, what is the dependency of absorption and emission? It is depending upon frequency mu and c velocity of light to the cubic power. So these are Einstein's coefficients, and this is known as Einstein's relationship for absorption and emission of radiation. Thank you.